So today we will do the definition of sampling distribution. We have done the examples of how to find the sampling distribution. So sampling distribution of a statistic. What is the definition of this? So we have taken the samples, we have find out all the possible samples, and we have find out the statistic. Suppose this is the sample number you have. Suppose I have taken only 1, 2, 3. Then you have T as the statistics values having T1, T2 and T3, right? और इस स्टेटिस्टिक का नाम हमने अगर हमने यहाँ पे क्या ले लिया है, x बार ले लिया है, then you will find out this will be x1 bar, x2 bar and x3 bar. ठीक है जी. If you are finding the statistics s square, then it will be s1 square, s2 square and s3 square. ठीक है जी. So this is the total table. ये हमने एक टेबल जनरेट कर लिया जिसमें हमने सैंपल नंबर असाइन किया. स्टैटिस्टिक्स in general, the name of the statistic is T. If you are finding the mean, then mean will work as a sample mean, then it will work as a sample statistic. Now, so the set of, what is the definition? The set of values. The set of values of the statistic so obtained, जो हमने निकाली, so obtained one for each sample, one for each sample constitutes as sampling distribution. Constitutes as sampling distribution of a statistic, right? So here, for example, in the previous case, the values T1, T2, so on up to Tk, right? Determine the sampling distribution of the statistic T. Of the statistic T. ठीक है जी? In other words, statistic T, it may be mean, it may be sigma, it may be small s square, it may be small beta 1, coefficient of skewness, coefficient of kurtosis, ठीक है जी? It may be any function of sample values. In other words, statistics T may be regarded as a random variable. May be regarded as a random variable which takes the values, T1, which takes the values T1, T2, T3, so on up to Tk, right? And we can compute various constants like mean, variance, skewness. यहाँ मैंने पहले लिख दिया. We can calculate various constants like mean, variance, skewness, kurtosis, etc. For this distribution, for its distribution. So this is all about the sampling distribution of a statistics. So, or the set of values that the random variable T will take, that will constitute the distribution of that statistics. Now, next is the standard error. standard error. In general, you have a univariate data and we can find the standard deviation from that data. So when we try to find out the standard deviation of the sampling distribution of a statistics, then that standard deviation is called the standard error. So the definition is the standard deviation of the sampling distribution of a statistic is called known as standard error. यानी स्टैंडर्ड डेविएशन का ही दूसरा नाम स्टैंडर्ड एरर है किस केस में, जब हम स्टैंडर्ड डेविएशन निकालते हैं सैम्पलिंग डिस्ट्रीब्यूशन ऑफ अ स्टैटिस्टिक का. ठीक है जी. So we have given some standard errors. हमें हमारे पास standard errors होते हैं. Suppose करो हमारे पास sample mean statistic है. So we have a table for that. So sample mean अगर x bar है for large sample, दो तरह के samples होते हैं, large sample and small sample. So we will discuss it one by one. So large samples के लिए if we have the statistic x bar, then what will be its standard error? Here I am writing the standard deviation or standard error, and here I will write the statistic. ठीक है जी. So mean के लिए जो standard error होता है that is sigma by n. So you have to remember all the, and similarly standard deviation के लिए होता है sigma square by 2n its under root, right? And then sample variance के लिए होता है, that is sample variance के लिए sigma square and 2 upon n. So इस तरह से we have the standard deviation of the statistic, sample median, sample correlation coefficient, movement, then there are so many. Is it clear? So now first of all, now we will come to the chi-square distribution, the sampling distribution. Now we will come to the exact sampling distributions. Exact sampling distributions. उसमें सबसे पहले we will do distributions. So first of all, we will do chi-square distribution. New distribution है, you have already known about the binomial, normal, Poisson. ठीक है जी, ये सारी आपको पता है. अब जो आज नई हमने शुरू करनी है, that is the sampling distribution. The name is the chi-square distribution, right? So सबसे पहले this is denoted by this, or you can write chi-square distribution, right? So first of all, we really have to define what is chi-square variate. First of all, we will do the definition of chi-square variate. The square of the standard normal variate. The square of the standard normal variate is known as chi-square variate. The square of the standard normal variate is known as chi-square variate. ठीक है जी? With 1 degrees of freedom. With 1 degrees of freedom. So what does it mean? How we will write it numerically? कैसे लिखेंगे? If x follows normal distribution with mean mu and variance sigma square, then z is a standard normal distribution, and this is x minus mu upon sigma. This follows n01. ठीक है जी, हमें पता है कि this follows n01. तो अब हमने z का करना है square, that is x minus mu upon sigma its whole square is इसका नाम है chi-square variate with 1 degree of, because we have taken only one variable x, so that's why we are writing here 1 degrees of freedom. In general, if capital I running from 1 to n are n independent, normal variates with means mu I, and variance sigma I square, then कितने लिए हमने n लिए, then what is chi-square? इन सबका summation I running from 1 to n xi minus mu by sigma whole square. कितने variates को हमने add कर दिया n को. This is also a chi-square variate, right? With how many degrees of freedom? With n degrees of freedom. So this is the first we have done the definition of chi-square. हमारा टॉपिक चल रहा है chi-square distribution, right? उसमें सबसे पहले we have defined chi-square variate. So the next we will do, what is the PDF? What is the PDF of chi-square distribution? Right? सबसे पहला हमारा टास्क है to find the probability density function of chi-square distribution, right? So let's start. Derive. Question क्या आएगा? Derive the PDF of chi-square distribution. Right? जैसे normal distribution का आपने PDF आपको पता है क्या है, right? कि वो continuous distribution है. If I am talking about PDF, it means chi-square distribution will be a continuous distribution, right? Binomial और जो Poisson distribution है उनका PMF होता है, probability mass function, right? So this is the difference between continuous function and probability mass function. Now, how to derive the PDF? So we will derive the PDF of chi-square distribution by using movement generating function. ठीक है जी? So by method of movement generating function, right? So सबसे पहले हमने independent, ये याद रखना है, we have the independent and independent normal variate. So let xi I running from 1 to n, we will write I running from 1 to n are independent normal variates, right? With mean mu and variance sigma squares. Then we want to find the distribution, क्योंकि हमने पहले chi-square variate define किया. chi-square variate is the square of the standard normal variate. इसका मतलब अब हमने उस variate को के लिए MGF find out करना है. So we want the distribution of chi-square, which is equal to summation I running from 1 to n xi minus mu by sigma whole square. So we will name it, this is as ui square. And that is where ui is equal to xi minus mu upon sigma I. And it follows normal distribution with mean 0 and variance 1. क्योंकि ये standard, ये कौन सा variate है? ये standard normal variate. This is the standard normal variate, right? So let's proceed further. Now, since all xi's are independent, right? अगर सारे xi independent है तो जो ui variable है, therefore all ui's are also independent. Then now we want to find the movement generating function of chi-square. So you will put the value here. This is summation of ui square t. So that is, आपको पता है जब इंडिपेंडेंट होते हैं तो समेशन किस में कन्वर्ट हो जाता है, प्रोडक्ट में. This is one of the property of movement generating function. When the variables are independent, then the MGF of the sum is equal to product of MGF. This is M of ui square t, right? And all are independent, identically distributed. So जब आप इसको खोलेंगे तो ये हो जाएगा whole raised to power n, right? So now let it be number 1. Now we will solve this, then we will take its raised to power n at the end. So now we will take m of ui squared t. So this is the formula, is expectation of e raised to power t ui square. And it is a continuous distribution, क्योंकि normal distribution में जा रहे हैं. chi-square variate कैसे बना है? Normal से बना है, ठीक है. Normal क्या है? Continuous distribution है. So this is expected of t of ui square into f of xi into dxi. So this is all about for the how to find the MGF. So we will continue tomorrow with the same lecture, right?